Hi, I'm Michael Mulligan. I live in Hinsdale, New Hampshire, right across from Vermont Yankee. I'm a nuclear safety advocate and a whistleblower. I worked on submarines for 4 years while I operated a submarine, the power plant, and I worked in the industry for 13 years at Vermont Yankee and stuff. So anyways, I was kind of, the Pilgrim blizzard and stuff. I was kind of do some kind of, just looking around what was going on today, and I looked onto the reactor operators. I forget what they call it, society of some sort, and noticed that Arkansas 1 and 2 inspection report, they had a lot of violation findings and stuff. It's really awful. They had so many violations, and one inspection report they had 11. So then I kind of started saying, what's this all mean? What's this all mean? I started going around and we know Pilgrim and their blizzard and their safety relief valves. They put in 2000 the early part of 2011 new safety relief valves. It took a year. Didn't even get through one operating cycle. It took a year for the first safety relief valve to start failing. Then 2 weeks later, another caused them to go to a shutdown. Another 2 weeks later, another safety relief valve started leaking, caused another shutdown, and then February 3rd they had another one that caused them to go down power to 80% until they slammed into the blizzard, and they were operating at power during the blizzard, and the transmission lines going into the plant were opening and shutting crazily, I guess, and eventually caused the plant to shut down. So I'm saying, what? Is this, we're seeing this? Is this just coincidence, Indian Point? With their scram, is coincidence? The misoperation of the plant during the blizzard, the SRV problems, and all that sort of stuff. Is this? How can I explain this? And this is not a local issue. This is a systemic issue throughout energy. It's really a dangerous systemic issue throughout energy, and and the question is, well, how can I show you and stuff? And so that's what I'm trying to do here right now, just to try to explain that. Here we go. Let's talk about an issue at Arkansas 2, and the event occurred September 8th, 2012. And I just give you an idea. The report date was a month later. It's not too bad. Less than a month later. And so let's just see. The NRC inspection report stated February 13th, 2003. This is when we first see it in the inspection report. The LER was on the internet, but this is when the NRC first brings up the issue. And I just, this kind of system documents ROP cycle, where event happens, and then 3 or 4 months later on. This is the kind of stuff that this document system was designed for. When they created this document system, when the industry first was born, and then eventually they learned through TMI that they have to have a system of documents and inspections. They have a frequency of inspections, not just when they felt like it, but every 4 times a year, a system, and so then the system was predicated on it was a paperwork world. It was all we had is the mail system, and we had faxes, of course, and stuff like that. But it was basically all done across our U.S. mail system, and so it was all designed to consider that they had to mail this stuff, and then they had to make an analysis of it. But essentially, it was because of the mail system that the NRC operates in that same cycle, that mentality of we don't have to get things out until 3 or 4 or 5 months later on, and we don't have to respond to the public's needs quite immediately in the internet age and the age of instant communication throughout the planet and stuff like that. And so that's what you get with the NRC, and still in a paperwork mode. It's still in a snail mail mode and not in the email mode. There's no reason why these inspection reports could come out and be more current, and could be more. They just don't throw out paragraphs at you and nobody can talk about them and stuff like that. And the NRC could interact with the interest parties in the community and people who have experience and stuff like that. It's just amazing how we haven't gotten away from the 1970s and into the the 2013 year type of stuff where revolutions are made over the internet instantaneously, but the NRC can't be responsive to the people instead of in this paperwork mode. So anyways, we're going to go down and talk about Arkansas 2, and they had a a fiasco with their with a condenser vacuum pump solenoid valves, and this kind of explains a lot about what's going on with energy. These are these silly operational maintenance employees, as far as not knowing their equipment and their procedures, and this thing is bigger than most people don't see it and stuff like that. But it's big, it's huge. These types of insanity with people not knowing how their equipment is running and their procedures and their purchasing bad components and equipment and stuff like that. It's the Three Stooges in a lot of ways, and a lot of these inspection reports that we're going to talk about, Arkansas, Cooper, Grand Gulf, and we're going to see, I guess, I don't know, those that have got the big guys today that really pop out of there with a lot of violations and stuff like that. And what's the nature of those violations? How come they seem to be worse than normal? So in Arkansas 2, they had a plant trip over doing a simple, a simple. They were doing a surveillance on a vacuum pump, and evidently they were checking the oil level in the pump, and the pump has to be operating in order for them to check the oil level. And a 2 solenoid valve failed. I guess it takes 2 for them to line up to have a direct path to the main condenser. A direct path to the atmosphere, and so when they had these 2 solenoid valves misoperate, and they provided a direct path to the atmosphere into the main condenser. They lost vacuum, and they tripped the plant, and that type and that type of thing. So. It's amazing. The licensee performed a root cause evaluation. The root cause was an inadequate design change that called for the installation of ASCO 8 342 model solenoid valve. These solenoid valves were not designed to be operated in a high temperature environment such as an existing turbine building. The license further determined between 2008 and 2012 several condition reports were identifying degraded sluggish performance of the solenoid valves associated with Unit 2 vacuum control pumps. These are brand new valves. They stuck in the stuck in the system, and they failed within the first cycle. You remember Vermont Yankee? They put in brand new safety relief valves, and the threaded seal. Basically, a year later, they started failing on them and stuff, and it was found to be wrong gasket material they were using in those SRV actuators. Well, this is very similar to that. I mean, you remember that in Pilgrim plant, these are ASCO valves, but Vermont Yankee and Pilgrim are Target Rock. I don't know what I'm not sure exactly what who makes the actuators for the SRV valves and stuff like that. Were they manufactured by Target Rock or were they ASCO valves? I'm not sure and stuff. And so you notice that the operators, God bless them, they're right on the spot. They noticed that these valves were misbehaving and sluggish and stuff like that, and they're trying as hard as they can to write the solenoid valves were not the licensing for between 2008 and 2012. Several condition reports were initiating identifying degraded, sluggish performance of the solenoid valves associated with the number 2 vacuum pumps. The auxiliary operators were identifying degraded solenoid valves performance within 4 to 6 months after installation of the new valves. 4 to 6 months, and something's wrong, and these guys don't have the wherewithal to kind of research that sort of stuff and immediately pick up it's the wrong material valves, the wrong quality valves, and we got to yank that stuff out of there as quick as we can and replace it with valves that can survive many years of plant operation and stuff like that. The idea that they're putting poor quality valves in there in the beginning, right? Probably trying to save a couple of pennies. And then the idea that it bites them in the ass within 6 months and it start causing problems. And these guys are just banging around in this crazy bureaucratic system and this maintenance system with their priority and their budgets and all that crap and stuff like that. And they know there's going to be problems down the lines, and they can't make the system work for them. In other words, work for them. They did the best they could to identify that. The sluggish valves, but the engineers should have been smart enough before, the college degree guys, engineers, should have been smart enough to never tolerate such poor quality components going into that kind of system that is going to challenge plant operations. It costs a lot of money, these trips and stuff like that. This is a totally preventable trip that shouldn't have been in there, and it just looks so poorly on energy when they have these kind of problems with purchasing bad equipment and then having these trips. And nobody is there's nothing out there that says trying to help energy. You got to play the game different. You can't allow this stuff to continue on and get worse and worse and keep challenging these plants and damaging your reputation. There's just nothing out there that hits energy with a tap on the head, hopefully, so that they'll say we need a change of behavior and stuff. I guess they changed their CEO, but it looks like they're doing the same old stuff. The CEO's not taking charge. He's just another caretaker like the last guy. The original preventative maintenance plan. So then they decided, oh well, we've got 120 degree qualified valves in there, and we think it's now inside this panel is probably 150 degrees, and solenoid valves themselves can throw about 200 degrees of heat and stuff like that. And so, I mean, this is how utterly insane they are. This is crazy stuff. Not just for a nuclear plant, for a fossil plant. This is crazy thinking for a fossil plant to ever tolerate this kind of stuff going on. So the original preventative maintenance plan, after they discovered that it was poor quality valves, was to replace the solenoid valves every 3 years. Not get the right, not sit there, engineering wise, and not to set up this system to say, have a temperature recording device in that cabinet, and get an idea of what the environment is, and then engineer in a huge safety margin. Maybe it was 150, maybe 200 degrees or a 250 degree material for that solenoid valve, just to make sure that damn thing, the elastomers don't degrade in there. I mean, that's the kind of engineering thinking, safe and causing the plant to be reliable thinking you think these engineers would be thinking about, but they don't. And so then the fallback is, well, we'll just replace those solenoid valves every 3 years, because they're not the right kind of valves. They can't stand the right kind of heated temperature. Then the next sin is to sit there and say, you know what, the chances of the bureaucracy replacing those valves every 3 years or every year and a half, what it ends up being and stuff, is slim to none. The idea that, if you have a mentality, just imagine it. The mentality of this. You have a plant like Arkansas 2 that's probably got more than a million parts, maybe 500,000 parts in there, and the quality drives you to the point that it's supposed to drive you to the point. You have all these components in there. You got to have good quality in there, and all the parts, unless. If you don't want to spend the money on quality, then the parts break down really quick. And with 500,000 parts in a plant, or a million, maybe 5 million parts in a plant, every day something's going to break and to trip you off the line, or that type of thing. Or it could be a lot less than that. Of course, like every 3 or 4 months and stuff like that. And next thing you know, you're tripping every 3 or 4 months on these silly broken down poor quality parts and stuff. And so that's what you're dealing with. I mean, that's what a good operator would be thinking. He has seen a lot of plant trips, and he knows how many parts. He knows how many parts are in that plant, and he can. In his head, he can see that if you have 500,000 parts in a plant, and you don't have the proper quality parts, then there's just going to be nothing but headaches down the line and stuff like that. So there they are. I mean, that's one of the things. And like I said, then the bureaucracy, the maintenance system, and to replace that part every 3 years is such a burden on the system. If you have 500 parts and you're doing that kind of stuff, how quickly you'll overwhelm all the engineers over there in support and the supply system, how quickly poor quality ends up overloading everybody with rules and broken parts and repair part streams and all that sort of stuff. It's insanity to even think that you would have a part like a solenoid valve and saying, oh well, we got the wrong quality part. The fix is we're going to replace it every 3 years. I mean, a good operator would say, "Oh, that kind of attitude, you're guaranteeing in the next year and a half, especially at the 3-year point, you're going to miss that, and you're going to miss it again, and you're going to get us into trouble. And it's going to, if you have 500,000 parts in that plant, that kind of attitude is extremely dangerous for me having a job at the plant, because it's going to get so destructive that eventually it's going to back up into the public's eye, and everybody's going to have a bad opinion of what's going on here." So, and that's the, and we'll go to the LER. Did I give you that? We'll give you the, I'm trying to give you the inspection report. 2000 and, nope, sorry. 2012-005, and so the LER is LER 2012-001-00. And like I said, this is quite a long time, a long way from coming out with an inspection report. So degraded condenser vacuum due to failure of the condenser vacuum pump solenoid valve results in a main turbine trip and subsequent automatic trip. So then they, and this guy starts talking about the ambient trips. The 2C5B condenser vacuum pump, one of two. This is another terrible symptom that something's bigger than this is going on. One of two condenser pumps has been secured by taking the control hand switch to the pull to lock by operations personnel to perform routine oil level checks. Shutting the pump off to check the oil levels. It's such a simple operation. The ambient temperature was low enough to maintain usually you don't have a lot of plants I worked on, they had air ejectors and they didn't need the condenser pumps, but I don't know the guys down south what they do. The root cause investigation determined that the subject solenoid valves were installed in an environment with temperatures in excess of design temperature ratings. This condition resulted in heat-related binding of the solenoid valves and failure to reposition when de-energized. There's that funny word somewhere here, the elastomers, they're gasket rubber type of material. Oh boy, well, they had a pressure switch. I mean, there was two problems with this thing. There was a pressure switch, which is different than the solenoid valves, that was misbehaving. So in this little simple thing, you had a pressure switch that was misfunctioning, and they knew about it, and also the solenoid valves that they knew were slow and something was wrong with it, and they actually knew that they were not environmentally qualified for the temperatures and stuff. So there's two problems with this two broken components that they're trying to operate equipment across. And if that ain't a sign of big danger ahead, when people are, even though this is not a nuclear safety system, although it trips the reactor plant, and it also makes it very expensive for the ratepayers to keep paying for shutting down a plant and starting it back up a week worth of operations. I don't know what it is. Is it $1 million a day? Is it $1 million a day, $1.5 million a day these guys lose and stuff? So that's very dangerous. So it's a simultaneous failure of two ASCO model 8342 valves that were installed in an environment outside the temperature limits. They don't say if they paid a vendor to put these cabinets in there with these valves in there, and they were sloppy with knowing what kind of a solenoid valve environment these guys were going into, or whether this was actually done by more hands-on type of thing with energy designing this cabinet, and they screwing up. But anyway, you look at it, this is just such a gross, obscene failure of energy to not know that having poor quality and environmentally unqualified valves is going to, especially with an air operator, is going to lead to. Plus, they knew it was broken, and they still kept going on. And I don't know if they went down to, once it was, once it started being sluggish, then they decided they were going to change it every year and a half. Instead of not doing the right thing and wiping it clean and putting a new valve in there immediately and stuff like that, then they're going to, play around with changing out the, valve like a gasket, like a spark plug, but changing out the valve every actuator, air-operated actuator every a year and a half to 3 years. I mean, it's insane to think a plant would ever operate like that they wouldn't immediately know. Like I said, especially if you're in a machine that has a million moving parts and stuff like that. If that attitude carries through to all those parts and stuff like that, you're just gonna lose track of what you're doing. It's gonna get too complicated really. It's gonna get complicated really quick, and you won't be able to see your. You won't be able to. You'll be overwhelmed with complexity very quickly. So that's what I wanted to talk about. Arkansas too, and that's because, like I said, it's so similar to Vermont Yankee with their safety relief valves, their actuators that are safety relief valves, the threaded seal, like I've talked about over and over again. And Fort Calhoun with having bad actuators, not environmentally qualified actuators, and Peach Bottom is in the same boat with their safety relief valves, air actuators, and now we got these more or less secondary system, their turbine system or their main condenser vacuum system with poor quality valves that ended up causing a plant trip. And like I say, what is this? What's going on here? What's the big picture? How come they're getting all these bad parts? How come these completely different situations and 3 different plants? They talk about new components, new valves going into a plant, and then they failing within the first cycle, within the first operational cycle, over there shortly. And stuff like that. What's going on here? And then I say to myself, okay, a plant has, you start thinking systems. What's the system behind this? And the system behind it, this is an extraordinary complex machine and people organization, right? I haven't even talked about the people, how complex people interact with all their procedures. They got books, not one book, but books that long. Just operating procedures, and as far as racks of procedures that no human being could possibly comprehend them all, and type of thing. Like I'm saying, a plant that has 500,000 to 5 million moving components inside their plants, and then you start saying to yourself, oh well, we got 104 plants. And each of those plants has, we'll just say, 2 million moving parts, and then you're talking about extraordinary complexity. Hundreds of millions of moving parts or more in this big system of all the plants and stuff like that. And if you start cutting quality in the system as a whole, then the 104 plants are going to shortly feel the wrath of all this poor quality equipment. That's what you're worried about. That's when you start trying to think of the system. How big is the system, and where's the vulnerability? Where's the vulnerable point? So Mike Mulligan here. Thank you.